Something that came up recently in a chat was how to set your pole vector. And I actually went through a couple different ways on how to do that. And I thought I would just take that and make it into a quick YouTube here. Because it's one of those things that trips up riggers and animators all the time. Whether you're building a rig or you are doing a IKFK match and you want to make sure you have that exact same match so you don't get jitters and pops and things like that. And it can be frustrating if things aren't working quite right. So I have my basic T-Rex here from the library. I'll just hide him, and I have a very simple leg here from him. Actually, I'll get rid of all geometry real quick. Actually, no, you know what? I'll just hide the floor so I don't trip over that. What I'm going to do first, just duplicate this so we have a secondary version we can work with. So the first thing to look at is a very simple technique which ends up working more often than you'd think, which is just to snap a locator or an object to the knee. So what I'm going to do is create a locator, and I'm going to snap it to the knee. And there's multiple ways you can do this. I have a quick marking menu there for that. But what you can do is select your object, select that knee, and say Modify, Match Transformations. And I'm going to do All. And basically now it's just matching straight into where that is. Now I want to be careful when I move this. I can move it in X and in Y, but I don't want to change it in Z because it'll get my joint chain off axis. The way that IK works, it wants to bend in only one direction. So if you think of it, it's like you have a triangle here, and come here. Oh, that's why. Yep. There we go. You have a triangle here, and that triangle is where the joint chain can bend, right? So actually, just for fun, let's bind this guy. I don't know what that'll do. That'll just give us something to look at, right? So when you put an IK handle on there, it's always going to maintain that perfect triangle. It doesn't tend to skew and things like that. So I'm going to go back to this locator, and this is the first technique I'm going to show you. So I can actually go and just rotate this to give us something a little bit nicer looking. Because it's a locator, I don't necessarily want to freeze it. I can, and it's still going to work. But let's see what happens. So I'm going to pull that forward, and what I'll do is create a simple rotate plane IK handle. So I'll open this up, make sure I'm rotate plane. I'm going to go select the hip joint and then the ankle joint, and I'll select my locator, select my IK handle there, and I will create and we'll get a good angle on this. I'll create a pole vector constraint. So it's just going to tell it where to aim that. So now when I move this, it's moving my joint chain, right, the way I want it to. And when I created it, it put it in the exact right location, so it didn't get off axis. Let me do that again. I'll just move it off axis just a little bit on purpose and redo that. And you'll see what happens is you get that pop, right? So you don't want to get that pop. So snapping, surprisingly, works pretty well, especially if your joints are zeroed out and have the right information on them to start with. If you have an off-axis locator for your angles and stuff, it's going to give it something weird. All right, so we're pretty happy with that one. Now the second one I'm going to show you is one you can create when you already have an IK handle. And this is the way I've done it for years, and it also works with straight joints pretty well. So what I'm going to do is I'm going to keep that IK handle on there. I'll create a new locator, and just for fun, I will say PVC values loc. Okay, just I have some. Let's colorize it, I guess. Make it blue. There we go. Did that work? Oh, good, it worked. And what I will do is I'm going to snap it to the hip first, and then I'm going to freeze its information, freeze its transformation. And then what I'm going to do is I'm going to take the information straight from the pole vector itself. From the IK handle's pole vector information. So if we go up here and we look at the top of here, and I hit T, you can see I get this little control here, and that's actually aiming where the pole vector is aiming of my IK handle. So if I move this, you can see I get new values over there, right? So I pull it out, pull it down, You can see I get different values in there, right? It's that pull vector that tells it where to angle your joint chain. And incidentally, this guy here up top is known as the twist disk, if you can see that. That's the orientation that it can twist in, right? Okay, so what I can do is actually use that information on my locator here. So if I go back to my IK handle, I can see that my pull vector in X is 0, but my pull vector Y is -4 something. So I'll just, whoops, copy that straight to the Y value of my locator. And then the pull vector Z is 8.3 something. So I'll grab that and put it on my pull vector, my locator. And you'll see now that they're in the exact same position. And what I can do now is create that relationship and say pull vector, and it doesn't twist on us, which is great. Now what's cool about that technique is you can use that when you have an existing pull vector on pretty much any rig that's out there, because that pull vector information will always be out there. You may not always be able to get the joint chain information, which is what you need for, say, snapping to the knee, but you'll always have, as long as you're on IK handle, it'll have that pull vector information. And because of the way that the connections work, if I go ahead and do an input graph here, you can look and see, you can always get your start joint, right? So this information, this joint here, our hip joint, is the one that we want to snap to originally before we freeze that information. So I wrote a little script that'll actually do that based on just selecting the IK handle. And I will share that, probably in gumroad or something like that. So this one's called auto pull vector IK. Basically what it's going to do is just get that IK, get the information. At some point in here, it's going to get the root joint, which is using just a simple list connections. And from that, it snaps to that position, and then it puts the extra information into our, to move our locator out here. So let's see if it works. I'm going to go ahead and just run the script, and you'll see I get a curve out there now. And it has an aim constraint on it by default that looks back at this joint chain, and that's just to keep it in line so we know that we're in the right axis. I don't need to keep that. I can just delete that out of there if I don't want it. It also creates up the pull vector constraint. So now I have that, and you see I didn't get any flipping or movement when I created that. And oftentimes I'll create that either for an IK-FK match or when I'm creating the rig from scratch. So let's just do that one more time. But I'm going to do it so we can see the angle a little bit better. And I'll run the script. And you see I get no movement on my joint chain, which is what I want. Yeah, I'll keep it. But I'm going to get rid of, oops. I'm going to go get rid of the pull vector constraint itself. Okay, so a third way is actually using vector math. Ideally, you're just going to use a script for this because it's not like you're going to calculate it in your head, but I will show you a kind of a fun way to do it with geometry. So I'm going to hide my poly surface I created before, and I'm going to create a new one. Now, I don't think you'll ever do this, ever, but just know that it's there, and it may help you visualize vector math just a little bit. So I'm going to go back into my Create Polygon tool. I'm going to create that same poly surface again, and that's just going to give us the plane that we want for our pull vector to sit in. So what I'm going to do is actually go in here to the multi-cut tool. Come on. There we go, to that center. And I'm just going to find what kind of feels like 90 degrees. It doesn't have to be exactly 90 degrees because we've already got our position the way we want it to along this axis. So I'll create a locator again, and we'll call this poly PVC. I mean, it doesn't really matter what, this is just for example's sake. I'm using V to just snap it to the vertice, or the CV that's right there, or it is vertice. And I'm going to hold D and click Align on this edge that I created. So now I actually have my manipulator set up in the right position to follow this rotate plane. And to make sure that my locator has that information, I'm going to go to Modify, Bake Pivot, and watch what happens. See how the locator snaps to that position? It gives it values, and this is because it's a locator, it does that. So now when I drive this out here, I'm going to go ahead and create a new pull vector constraint. You see it lines it right up. And that's sort of the gist of what most of the scripts out there using vector math are doing. They're going to calculate the distance between here and calculate these angles and then calculate what this direction is and then drive out from it. So luckily the internet has provided lots of different scripts out there, so I just have one here. For Maya to use it, you need to use OpenMaya. So that's what this first line is doing here. And then this script here is just going to calculate those vectors, find that position, and actually create, what am I creating? I create something. Oh, for this, I'm just calculating the information. And then the second part, my build pull vector script, aim is on. It's actually going to create a locator and snap it to that position where it needs to be. So let's give that a shot. What do I need to select here? I select the joints. So I select joint, hip joint, knee joint, ankle joint. Creates up that triangular relationship. I'll make sure this is sourced correctly. I'm going to run my script, and it creates that locator for me. And again, if I make that connection, it's going to be right in the right place. I got no movement there. Now, where things get weird with this script is if you have a joint chain that doesn't have a clear, defined axis. So if I go into my side view here and create a perfectly straight joint chain, I'm going to give it a preferred angle. And we go in here and maybe give it a little bit of a twist like that and freeze it. We don't have to freeze it. If I select here, here, and here, and I run this, it will get the position of my locator correct. But what has it done for my rotations? So since there was no clear defining axis for my triangle there, it doesn't know where to put that. So I can't really move it and have it stay in axis to my joint chain. So just for the hell of it, let's put a IK handle on there. Come on, there we go. I'll select that locator, select that IK handle, and do create a pull vector constraint. And you see it pounces right off the bat because it's not going in the right position. So that's actually not going to work so great on a creation script because it's not going to put the pull vector in the right position. I can, however, like before, snap that locator to our joint chain. I'll create that pull vector relationship. And actually I can move this out in Y, and you see I'm not getting any flipping unless I cross the plane of the joints. And if I move this joint, this IK handle, it's actually pointing at that locator as it should, just as we'd want it to do. Kill the pull vector constraint. And then again, let me kill this. If I create a pull vector if I create an IK handle, by default, it's going to find that alignment exactly how it wants based on our preferred angle. So when I take that joint chain and I rotate it and say set preferred angle, it's telling the IK handle which way it wants to bend that to calculate that positioning. And if I select the joint, you actually can see that the joint has a channel on it, or an attribute on it, called preferred angle. So I can actually go in here and just type in which angle it is that I want to use. And so, yep, there it is. And so I can use that other script that uses the pull vector itself and snags its information. So let me just, so if you look up here, here's our pull vector information. Let's see if this actually works. I'll select that locator, or the pull vector itself. I'm going to resource this, even though I don't need to. Oh, wrong one. Sorry. I want the auto pull vector one, which is the one that uses the information. I'm going to select that. Select the IK handle. Run auto pull vector. And you see it gives me that control setup. It looks a little angular off, but the good thing is that my Z value is where it needs to be, right? So you might actually have to fix this up, script up just a little bit. I don't need to keep that aim constraint. So as long as I stay in Z, it's going to work. If I work in Y, it's not going to work. So let's see if I can fix this script real quick. So what I'm going to do is create a new aim constraint. There we are. Cool. Now what you can do with an aim constraint is actually give it an up vector. So an up vector is just a secondary axis for your aims. So my first aim, which is going to be in its z-axis, is going to be that, and then I'm going to do a negative y-axis, so this axis going north and south, and then I'm going to use my secondary to me. I'm actually going to just use my IK handle. So I'll select that information here. When you change your world up type to object up, you need to actually type in the name of the world up object. So let's see if this works. I'm going to select the joint, select the group above my control, and I don't need to select the world up object because I have to actually put it in there. And I'll hit apply. I don't know if this is going to work or not. Oh, look at that. And now I'm going to go here and just delete that aim constraint. And what's cool about that is now I'm perfectly aligned in the right axis for my joint chain to work. Or my pull vector to work. So it's now going the right direction. Actually, in fact, while I'm here, I'll just fix this script. Let's see here. World up type object I want, and world up type blah, blah, blah I want. Okay, so let's grab those things. Bear with me. Where's my aim constraint? Aim constraint, there it is. Okay, drop this in temporarily. Take that and drop that in there. Whoops. And world up object equals. All right, let's take this, kill it. It's going to be RK. Yeah, our IK. Sorry, IK. Sounds like I said RK. All right, let's Oh, I forgot the equals. Perfect. Cool. So let's see how that works. Let's take this guy, delete it. Just for fun, let's delete our IK handle. Sorry, I got glare that you guys can't see. Create an IK handle. Okay, select the IK handle and run to pull vector. You know what? We weren't in a good angle to see if it moved or not. So let's redo that. Select the IK handle. Do auto pull vector. Cool. And it looks like we're aimed exactly how we want to be, which is cool. And the last thing I do, actually, since I'm here, I will just clean this too, is let's do aim con equals that, and then do trans dot delete aim con. Because we don't want to keep that, we don't necessarily want that information around. So I'm going to go ahead and go blink, and I will run it. Cool. So now we have the upper group does all the alignment work. The control curve itself is zeroed out because it's just following its parent. And now if I pull that out in Z and Y, or if I use the translate or the X axis multi-axis transform there, it all still works the way it wants to, and I should be good. Now the other thing to keep in mind, just so you know, I wouldn't want to use the IK handle directly, and you notice that its axes are off as well because it just goes to world space. It doesn't care. But if I was to say, let's do a world circle, a nerve circle, a group it to itself, I will snap it to this guy here and freeze its transformations. So I actually have, I snapped it to the joint itself to get the orientation, and I'm just going to parent the IK handle underneath that control. If you care, you can always go in here and, oops, and give it a better access. If I, whoa, come on. There we go. There we go. Cool. And now when I move it around, it's actually moving in the axis of the joint, which is how you'd expect it to as an animator. Cool. So I hope that helps. I'll put the scripts up probably in my Gumroad, but maybe just in the information underneath. I haven't decided yet. And just sort of why you'd use one over the other. I'm still always amazed at how well the just snap to works. If I take that out, put there, I can actually snap this here. You notice I didn't get any change in my, oops, not that. Where's the, there it is. Even if I snap the group there, oh, because I moved it. Stop moving. I should be able to snap this right to it. Yeah. So even the straight joint snapping to that knee joint works pretty well. So I hope that's helpful. And if you have any questions, let me know. And I'll see you next time.